এখানে কোশ্চেনটা কি বললো? এখানে কোশ্চেন হলো যে a ball is thrown vertically upwards. Its distance is from a fixed point varies with time t according to the flowing graph. Calculate the velocity of projection of the ball. Calculate the velocity of the projection of the ball. তাহলে এখানে কোশ্চেনটা আমরা যদি ফার্স্ট অ্যানালাইসিস করি, কোশ্চেনটা অ্যানালাইসিস করলে আমরা কি দেখতে পাচ্ছি? কোশ্চেনটা অ্যানালাইসিস করলে আমরা দেখতে পাচ্ছি যে একটা বলকে থ্রো করা হলো উপরের দিকে। কোন দিকে? একটা বলকে উপরের দিকে থ্রো করা হলো। তাহলে একটা বলকে যদি উপরের দিকে থ্রো করা হয়, তাহলে তার মানে পাথটা কেমন হবে দেখতে? একটা বলকে যদি জাস্ট উপরের দিকে থ্রো করা হয়, ইফ আ বল ইজ থ্রোন ভার্টিক্যালি আপওয়ার্ড, দেন হোয়াট শুড বি ইটস পাথ লুকস লাইক? তাহলে কেমন হবে এর পাথটা দেখতে? এটা মনে করো এখানে একটা স্টার্টিং পয়েন্ট যেখান থেকে মোশনটা স্টার্ট হচ্ছিল। এখান থেকে কি, এটা হলো আমাদের স্টার্টিং পয়েন্ট যেখান থেকে মোশনটা স্টার্ট হচ্ছিল। তাহলে এখান থেকে যদি আপওয়ার্ড ডিরেকশনে যায় সেটা, তাহলে এই পথ ধরেই যাবে সেটা। The particle will continue this path. Yes or no? So let this is our starting point when the object is thrown, and initially it is starting vertically upward, moving. Initially it is starting but moving vertically upward. So in this way, the particle will move or travel along this line, because this motion is the motion under gravity only, and motion is also vertical motion. Now, if we see or analyze the question, it is given in our question that a ball is thrown vertically upwards. Its distance is from a fixed point. So it is already mentioned in our question that its distance is from a fixed point. So let the fixed point, now we have to note or understand that here the mentioned point or the fixed point which is mentioned here, it is not the point from where the object is thrown. So this the red line. Red line is only indicating the path on which the object is moving. But let there is a point where the object is thrown. So let the object may be at this point. The fixed point may be at this point also. The fixed point may be at this point. Fixed point may be at this point also. The fixed point may be at this point also. The fixed point may also be at this point, at this point, at this point, and so on. So let the particle is starting from the point O. Let the particle is starting moving from the point O. So it's from starting, it is moving. Initially, it is moving vertically upward. And it is also mentioned that if we analyze our graph, then we're seeing that its starting distance is S1 equal to 6 root 5. So this distance is, let from this distance to, if this is the fixed distance, this distance must be 6 root 5, or this distance is equal to 6 root 5, or this distance, or this distance, or this distance, etc. But if we suppose we are taking that the object is throwing from this point. If the object is throwing from this point, then initially the initial separation between the fixed point, it is our fixed point. Let fixed point is F. So this is our fixed point, then we're observing that the initial distance is the least distance or minimum distance. Then after gradually, as the object is moving upward, so this is one moment, this is the next moment, this is the next moment, this is the next moment, and so on. It is gradually moving upward. So at the next moment, the distance from the fixed point to the object is this now. And after some moment or after some time, this distance will be at this point. Yes or no? And after some time, this will be also be like this. So if the point of observation or the fixed point is here, if, then we're seeing that the distance is gradually increases. But here it is given in your question that the object is the distance or separation from the point of observation, or from a fixed point to the point from where object is thrown is gradually decreasing. It is given in our question. So this must not be possible. This case will not, uh, it is not indicated or it is not given in our question as per our discussion. So let the point is here, f is here. If the point is here, then what it will be? If the point is f is here, then let this is our initial distance. If this is the initial distance, then next distance will be this. Next distance will be equal to this one. Next distance will be this one. So from this graph, we are again seeing that the distance, the distance of the moving point to the fixed point is gradually increasing. So this is also not possible. Let this is our fixed point f. So if the object is moving from this point, this is our point of observation, or this is the fixed point, and the object is moving along this red marked line, then it is, if this is our starting point, then after some time this is the next position of the particle, this is the next position of the particle. So according to our consideration, the distance is again in gradually increasing. So this is also not possible. So this three condition is not possible. Also this three condition is not possible because this left side or right side is mirror image of one another. So if this is not possible, this also not be possible. If this is not possible, this also not be possible, etc. So the hour up to this region, it is our the point of rejection. Up to this region, it is not possible as per our given question, because in this range, if the object is the fixed point is lying in between this range, in that case, the separation between the fixed point and the moving point is only gradually increases. It never decreases. So as per that, it is not possible. So it must be, the fixed point must be located somewhere above this level. So if this is above if the fixed point is lying above this level, let this is our fixed point. So f. Now if we consider this is our fixed point, then if we consider, so this should be our starting distance or initial distance. Now this should be our starting or initial distance. Now this should be our starting or initial distance. After that, this is our next distance. After that, this is our next distance. Next distance is this. Now from this analysis, we are seeing that this is the highest distance. After that, it is less than the previous one. After this separation or distance is less than that previous one, and this is the least or the minimum distance. And after achieving this point, or when the particle is reaches from the point of thrown to the parallel line, where the object is point of observation or fixed point is lying, then the separation between them is minimum. After that, it is again going upward. So then it is again increasing, and so on. So from, if we take our fixed point here, then we can see that the initial distance is large, starting distance or starting separation is large. After that, it is decreasing. After that, it is decreasing up to a certain values, and after it will, at a certain moment, it will be minimum. This is our minimum value, and after that, it is further increasing. So it is after that increasing of value, after certain moment, it will, the distance will be equal to in an intermediate value, but there is a symmetrical point. Now we are considering, yes, we're seeing that there is a symmetrical point. If we take a mirror here, or if you place a mirror here, then we're observing that. If we place a mirror here, then we're observing that the left side is the mirror, is the image of the right side, or right side is the mirror of the left side. So what is the meaning of the mirror image here? The meaning of the mirror image is nothing but the opposite situation. So what is the significance, or what is we're understanding by the opposite situation. Here opposite situation means initially the object is moving in upward direction, and its opposite situation means the object is moving downward. So downward in starting it is moving upward, and its opposite situation is moving downward. So from this opposite phenomena is just starting from here. So this is our critical or highest point. Then after this point the object is moving down again. Okay, so first of all we can say that the fixed point may be, or fixed point lie at the circumference of a circle. At the circumference of circle, the fixed point is lying at the circumference of circle. The fixed point is lying at the circumference of circle, but below portion. But up to our discussion, but which is discussed up to now, as per that discussion, it is not, this reason is rejected. It is not allowed as per our dis discussion. Then our accepted our accepted point is here. Now it is given in our question again that the starting separation is this one. So let this our starting separation, and it is given in our question as equal to, which is equal to 6 root 5. So this value must be equal to 6 root 5. This value must be equal to 6 root 5. And after that, when the separation is minimum, so our minimum separation is here. If this is our minimum separation, it is the least separation. It is given as 6. It is our distance 6, and it's symmetrical, but from where the motion is retrieving, or it is being the mirror image, or it is just changing its direction of motion, that point is equal to 10. And in our diagram, that point is here. But in our diagram, that point is lying here. So this is our final, this is the distance which is indicated by this point, which is nothing but 10. So this distance is equal to 10. Okay, so now if we are seeing that this is our right angle triangle, this is again a right angle triangle. These all are right angle triangles. So from this right angle triangle, this is the hypotenuse whose value is equal to 6 root 5, and this is the base. So this much distance equal to what? This much distance is, we can calculate this as under root by using Pythagoras theorem. That should be equal to 6 root 5. 6 root 5 square minus 6 root 5 squared minus 6 square. So now we can take the 6 as common. After taking 6 as common, the inside the square root there is nothing but 5 minus 1, which is equal to 4, and the square root of 4 equal to 2. So this distance equal to 12 meter. So up to this distance it is nothing but 12 meter. And again we can calculate the upward distance. Now again, so if we calculate the upper distance from the minimum separation point, this much distance, here the hypotenuse is equal to 10 and the base is equal to 6. So its height must be equal to, we can calculate this height equal to, that is equal to under root 10 square minus 6 square, which is nothing but equal to under root 64, which is equal to 8. So this distance equal to 8. So total distance, now this total distance is now becoming what? Now this total distance is nothing but it is becoming the aggregate of sum of these two distance. The below portion is 12 and upper portion is equal to 8. So total is equal to 8 plus 12, that is equal to 20. That is equal to 20 meter. Now we can apply. So let this our starting velocity. It is starting from here to in the upward direction. It is starting. The starting velocity is in the upward direction. So let this velocity is equal to u. And this is our final point. At final point, its velocity is becoming v. So now at final point, as the velocity is moving its direction, so at this point the velocity is equal to 0, v equal to 0. Now we can use the kinematic equation, And using that kinematic equation, we can write the equation as v square equal to u square minus 2gh. If we use this equation and after substituting the values, the value of v equal to what? It is, this value is equal to 0, u equal to u, and this is equal to 2 into g, value of g equal to 10, and h equal to nothing but 20. So if you substitute all this value, then we can write this equation as equal to 0 equal to u square minus 2 into 10 into 20, which is nothing but 400. Or we can conclude that the value of u square is what? U square is nothing but the starting velocity, which is equal to 400 meter per 400. Or we can write the starting velocity u equal to under root 400. So starting velocity in our given question, which is found as u equal to u, starting velocity u equal to 20 meter per second. So it is the solution of the question given in this situation.